Hello everyone. My name is Arun Lakshman. I am a OpenSearch focused analytical specialist at Amazon Web Services. Today, we are going to talk about the tools that are available for us to transform the data and analyze in OpenSearch. Amazon OpenSearch service is a fully managed service that makes it easy for you to deploy, operate, scale OpenSearch cluster. It also supports 19 different versions of legacy Elasticsearch clusters in the AWS cloud. OpenSearch is a fully open source, community driven analytical search and analytical suite derived from the Elasticsearch 7.10.2 and Kibana 7.10.2. The OpenSearch project consists of a search engine, that's OpenSearch, a visualization engine, that's OpenSearch dashboards, as well as a set of tools, plugins, and client libraries that helps easy for you to interact with OpenSearch cluster. The basic interaction flow works in this way. You have your source data that comes from various sources that gets converted to JSON documents by these tools, and it gets ingested into OpenSearch cluster. Once it is indexed, they become searchable instantly. With the provided API clients and OpenSearch dashboard, you can access the indexed data in the OpenSearch cluster. So the data sources can be like variety of range in different size and shapes, like the static resources, like your application data from your web application microservices or your business application databases, etc. Or it can be coming from a streaming, like your automotive or home devices or manufacturing pipeline. Or it can be a simple application data that sits in the databases. You need transformation when you are sending this data to OpenSearch cluster. Why you need transformation is basically the the sources can be verbose or noisy in nature. You want to filter out the noises and you want to ingest and analyze the data point which matters to you the most. Along the way, you might want to enrich your data by adding metadata like the instance name from where it gets generated, or you can use tags that tag your environment name or application name, or you might want to do some kind of computation, or simply you want to enrich your data with a third party system like adding a geo information to the IP address for your access logs, etc. So one option is to data prepper. Data prepper comes from open OpenSearch project. It helps you to simplify the collection and analysis of logs, traces, and metrics. It is a fully open source with the Apache license version 2.0. Fluentd is one of the popular option in this tool. It's a Fluentd is an open source data collector. It is a high performance and it has a built-in resilience. It can handle buffer in the memory or in the file system. Since it is written in a plugin ecosystem, the community has like over 1,000 plugins that are available for us to transform our data. It also supports streaming at the edge. It uses the common SQL language process to access the stream of logs. If you have a strict memory requirements, you can consider Fluent Bit. Fluent Bit and Fluentd share the same concepts, except the fact it's written in C. It is very suitable for to deploy and collect the logs and metrics from the Kubernetes cluster. You can forward the logs from Fluent Bit to Fluentd to process in a scale way. It also has a SQL streaming process that helps you to streaming at the edge. The other popular option is Logstash, which is popular for a very long time. You can construct a complex transformation, like you can filter, you can drop, you can add metadata. All of them you can do with Logstash. It also supports out of the box but most common log types like Apache common or error logs or combined logs or nginx logs, and it handles the batch as well. The one common con on this architecture is you might need to run this in the own hardware. You can also use a Lambda, which is a serverless native AWS solution. That's a big benefit over Logstash. You don't really have to manage, it's a serverless. The biggest downside is that you have to write everything that Logstash is doing, and you have to do everything in the code. So that it could be significant challenge, especially for complex log lines. And given that Logstash is a complex piece of technology, that is there a lot in Logstash. And the other thing that I have already mentioned is the concurrency. It it drives too much concurrency to the OpenSearch cluster. And there is no built-in error handling mechanism. All you need to do is in the code, you have to handle the errors. The other option is to write a custom code from the scratch. You can write, if none of these tools are working for you, probably you can write a fully custom code. Or if you have data collected in the streaming, like MSK or Kinesis or any messaging system, you can use Amazon Glue to process your data and send it to OpenSearch. Or you can use a Flink connector for OpenSearch or Kafka connector for OpenSearch. For some of these operations, like you can use managed services like Amazon Glue or MSK Connect to send data from Kafka to OpenSearch. The the main con is you may need to write a lot of complex code and manage on your own. In this demo, I'm going to start with a simple event processing with Apache Access Log Events, then enriching the log events with geo information. The third, filtering out the events and send the events to two different destinations in OpenSearch. Finally, with streaming at the edge, I will be aggregating the events based on custom enriched attributes of the event. Dive into that. Before we get into the demo, let's take a look at the structure of the Fluentbit data pipeline. It has three major components. One is input, that are your sources. Filter is basically for processing. And then you can emit your processed records to multiple destinations. Optionally, once it hits the storage tier, you can have an independent stream processor subsystem, which is a very powerful feature which we will see in the demo, where you can perform streaming operation at the edge that will greatly reduce the stress on the backend system, which is open source in our case. For this demo, I'm using Amazon Linux on an EC2 instance. I'm going to run the single line install command on my EC2 to install Fluentbit. Now it gets installed. Let's go to the demo directory. Let's take a look at the sample file. So this is the typical Apache access log, which we will be processing. It has about 3,000 lines in it. Fluentbit comes with pre-built parsers for most common log patterns like Apache logs, error logs, Nginx, Kubernetes, MongoDB, syslog, and you can write your own parser according to your data. Let's take a look at the Fluentbit data pipeline. So the first section is a service section. That's a service level configuration where our parser files is. And I have my input. I'm tailing the sample log file from the head, and I'm filtering it with the Apache 2 log parser, and I'm outputting it to my OpenSearch cluster. I'm leaving the Logstash format on, which helps to rotate the index daily based on the event timestamp. And the Logstash prefix is my index name. I'm disabling the output here because the output can be enabled during the development of this pipeline. Once it is stable, you can actually disable that. Otherwise, it will be very verbose in production. Before I run this, I want to watch the index in my OpenSearch cluster. So I'm going to watch. So currently I have three indices. Those are all like system indices in OpenSearch. Let's run this -c, where my configuration file is. So the moment I run this, you can see a new index has been created based on the event timestamp. Let's close this. So the next demo is to enrich the log lines with the geo information. For this, you need to download. For this, I'm using GeoLite. I can download this from MaxMind. Here is my geo database. Let's take a look at the configuration that uses this file. Here I have the additional filter section for GeoIP2 that matches the tag Apache log where my geo database is, and which key I should look for the host IP address. In this case, it is a host. Once it is resolved, I'm creating a new attribute in the data called country with a country name in English and the country code as ISO code. And I'm emitting this to a new index. Let's run this. Now you have this index created. Let's take a look at how this has been created. I'm going to the DevTools, run this command. Now I have this new index created. You can see a new attribute has been added to the index with the country and ISO code based on this host. Let's look at the third one. The third demo, we are going to filter events based on a status code. For this, I'm going to use a stream. So here is my streaming configuration. So in this configuration, I'm creating a stream task with the name HTTP code 401. I'm creating a new stream with the name HTTP 401 and tag the stream as HTTP 401 and selecting everything from Apache log, which is our sample log, where the code is 401. Let's take a look at the data pipeline. I'm using the stream file as a service configuration. The stream creates a tag HTTP 401. We are matching it in our output and sending it to a new index. So now we are collecting all the events that are collected in a stream to a separate index in OpenSearch. I'm just outputting it for our understanding in this demo. Let's run this configuration with JQ. Now all the events with the status code 401 are collected in a separate index here. Let's take a look at the fourth one. Here I'm creating a new stream, that is country stream, with the tag country data. I'm selecting country as a country name and counting all the events as a total number from the tag Apache log in every 5 seconds window, group by country. Let's take a look at the data pipeline for this. In this pipeline, I'm emitting the data on the standard out if it matches country data. Let's run this. Let's run this command. After 5 seconds, you can see the events have been aggregated by country and the count. This concludes the demo. Now you have a fair understanding of how Fluentbit works and how you can filter, process, and enrich your events with its plugin ecosystem and powerful stream processing at the edge. You can also write custom processes, parsers, and plugins. So since there are like multiple tools are available, you can choose wisely. Thank you.